Okay, so this is going to be the last video unless I decide to do some for the bonus. Um, so now we're going to talk about the big picture. For me, I like putting in the inputs and the outputs and parameters and constraints like I told you in the last video. It makes me feel like I'm getting something started, but we haven't really done the logic yet. So the first thing that we want to do is a state diagram. And let me get you started on that. Your state diagram will be different from mine. Okay, so you'll have a reset state, or I had a reset state. And in my reset state, let's see. The main thing for the reset state, let's see what it says in your instructions. When reset equals 1, the system resets explained in section 6. Let's find section 6. When reset equals 1, it should set lanes A, B, and E to green, and all their lanes to red. And the sequential circuit should examine lane A when the machine comes out of reset. Okay, so our output here, so the output is going to be YA, YB, and YE. YA, YB, and YE. And I did not have, I set my 7-segment display to off. Those were my outputs. And it always went from here to what I called state A, which was also 0, 0, 0, 1. And state A is the output, is state A, the lane that it checks, so the lane checked is A, and its outputs are YA, YB, and YE, and the 7-segment display shows A. Okay, so then where do you go from there? So this that depends on how you set up your state table. So on my state table, what I had, so when I did this right here, I had the next lane that I checked was D. This was called state B. On this one, I had lights A, B, and E on. On this one, I had B and D on. That's because the lane I checked was D, so I turned D on. The one I had after that, my next state was state E. And, I'm sorry, my next state 3, 0, 0, 1, 1, checks lane E. The state name is state C. And it turned on lights A, B, and E. Okay, so if I'm in state A, where do I go next? Well, that depends on traffic. So if there is traffic in lane D, then it's going to go to this state. So this is going to be, I'll call this was state B. And in state B, I had B and D were on, and I was checking lane D. So I'm going to go to this state if XD equals 1. That's when I'm going to go to this state. But if XD doesn't equal 1, I'm not going to go to state B. So if there's no traffic in lane D, I don't go to this one. Okay, so then what? Well, then I'm going to check to see if there's traffic in lane E. If there's traffic in lane E, then I'll go to that next state. And this checks lane E. The outputs, it turns on A, B, and E. This is how I did it. You don't have to do it this way. But it goes here if XE equals 1. Alright, well, what if there's no traffic in D or E? Well, what does it do next? Well, then, according to the way I set things up, the next thing I had was to check for C. Okay, so then it would go to the next state. This is state D. Wait, I don't have this defined yet. State D. This one, segment C. So it goes here if XC equals 1. And my outputs here doesn't matter, they were C and D. YC, YD. Okay, and then so forth. So first it's checking lane D, then it checks, and this is just how I set it up, it checked lane D, then it checked lane E, then it checked lane C, and then in mine, the way I had it set up, the next thing it did was it checked A again, and then F, and so I'm kind of going down, I am going down this column right here, checking those lanes, and the first time I find a lane with traffic, I go to that state. And if there's no traffic at all, this was not in the project description, but I decided that if there was no traffic at all, so this is or they all equal 0, so XA equals XB equals XC equals XD equals XE equals XF equals 0. If that's true, I also just advance. So if there's no traffic, I just advance through my states, just one at a time, and I come back and I go, and it goes all the way to state K, and then state K goes to state A. So that's if there's no traffic at all. If there is traffic, it checks the lanes in the order that I set up in my little table up here. It checks them in that order and then goes to the first state where there is traffic. So that's how that's set up. I completely lost my train of thought. I got a text saying that the grades on the test were out for one of my classes, but so I had to immediately check, and my grade wasn't there, and now I don't know what I'm talking about. Okay, so we have our various states, and we were talking about how you decide how to go from one state to another. So you set up your states in this table up here. Then when you are in a particular state, you decide what state you go to next based on the traffic. So how are you going to implement that in code? So the way you're going to implement it in code is you're going to take a look at Lab 7. Lab 7 is really going to give you a good idea, and you'll see the same ideas in SI Worksheet 5 and those videos, which I referred to in video 1. So you're going to have 2 always blocks. One always block is going to identify the properties of each state and what the next state will be. And this always block, this has the information from your state diagram. So I have my current state is named P. So my always block has always at P, begin, case P. Now if all I have is the one case statement, I don't need a begin and end, but case P. And then I have my different cases, and I say what I do in each case, and I say what my next case is. So I set which lights are on, and based on the traffic and my state diagram, I say what my next state should be. Also, for this basic functioning, I send the information to the 7-segment display. And I also included a default, and I have a reset state. So let me just show you a couple things. Okay, I don't want to give away too much, but so this is what I did with my reset state. For my reset state, I said that I turned on the lights for A, B, and E. The others are off. The reset state always goes to state A. My 7-segment display I set to off. Off was the parameter that I had up here. And AN is, for all of these, it's always going to be AN is going to 0, 1, 1, 1 because we're just in basic functioning. Okay, so I'm going to show you one more state, and that's it. And you have to figure out the others on your own. Or in your state, A doesn't have to be like this at all. And you don't have to do it like this. There's always like lots of ways to do things. So for my state A, what I said that was, well, first of all, when you come out of the reset, you are supposed to check lane A. So the state that I should go to out of the reset should be checking lane A, which is right here. So that state happens to be state 1. It's called state A, and these are the lights that I'm checking. So so I turn on lights A, B, and E. I send A to the 7-segment display because that was the lane that I checked that sent me here. And this AN just says it's the segment display on the far left. Then I determine which state I go to next. Now, I have it set that the next lane that I check is D. And so if D has traffic, then I go to state B. So if XD, then my next state is state B. Else, the next state that I check, according to my chart, was E. So else, if there's not traffic in D, but there is traffic in E, I go to state C. Else, I check A, and so forth. And I check all of my lanes because I don't want there to be traffic and me not address it. So I check all of my lanes, and if there's no traffic in any lane, then I say my next state is going to be state B. I just go to the next state. As in state A, I go to my next state. So state B, I do something similar. I turn on the correct lights. I decide what state I go to. And if there are no lights on at all, I go to state C. And so forth for all my states. Okay, so that's this always block. And this always block is always at P. So whenever my current state changes, I start calculating what my next state will be based on my switches. So this always block doesn't actually change the state. It looks at the present state and does the outputs based on the present state and computes the next state. So this is your state diagram. This always block is your state diagram. It gives you your outputs and computes the next state. You have to have a separate always block that goes to the next state. So your separate always block, let's go back to my document. Your second always block advances to the next state. For right now, it's based on the push button clock. So that means you should have always at positive edge button clock. That says button clock. doesn't look like it, but it does. So when you press the button clock, you see, am I in reset mode? If so, I go to reset state. Am I in load mode? If so, I load a state. If I am in neither reset mode nor load mode, then I need to make my current state the next state. So you'll have something along the lines of, if reset, let me just tell you the things that you want to go here. You want to turn on the reset LED, turn off the load LED. If it's on, you don't have to check to see if it's on, you just turn it off. And you want the next state to be the reset state. Okay, reset, that's what you check first. All right. Else, if load is on, then you want to turn the load LED on. You want to turn reset LED off. And you want the next state to be S. S is the state indicated by those last 5 switches. So it'll get the state from those switches. Else, so if it's not reset, it's not load, then P is your next state. The only other things that you might need here, let's see. Oh, now I can't save this because I've been writing all over it. But I got that error there. The only other things that I put in here was I turned off the reset LED and the load LED. Okay, so that is the basic functioning. What you should do is you should watch the video that I have that shows the BASIS board operating in this basic functioning mode.